Okay, so this next video is a logic block that I designed for a job where it wants to check the pump or the fan coil so that it doesn't start if it latches out in a fault. So at the moment you can see that we've got this check latch. Inside there is a logic. I'll explain all that lot in a bit. And then we've got the enable, the run of the inverter. Inverter is healthy. The fail time, how long we're going to wait until we know it's failed, and a reset. So as you can see at the moment, the fan coil or the pump, whatever you want, is healthy and we're enabled. So if I just take it off the enable, so action set, and I'll put it to false, you can see that the unit pump, let's call it a pump, the pump is false. It's still healthy, but we've got a manual run there. See, it's saying manual run here in the mode. That's because the inverter is actually giving a run signal. So if we've stopped it, that inverter should give it also a stop signal. So let's set that to stop. So we're now back to auto run. Inverter is healthy, we've got 30 seconds, no reset needed because there's no alarms, everything is okay. We enable the inverter or the pump. Now it's still saying manual run because it's expecting a feed from the inverter to say, hey, we're running, or the DP. So let's just activate that. Now we've got the enable, everything's healthy, and there's no fail time, there's no fail countdown there, everything is healthy. So not failed, true, and we're running. We've got the run signal there. We take the inverter run off, make it inactive. So we've got the enable still, we've got the manual run, so it knows it's in manual now. Someone started that inverter and we haven't got the run signal. Or let's do it the other way. Let's just do set that, not set because I've overridden it, actions, emergency auto, actions, we'll leave that as true, set to true. Now we've got the alarm there. Let me just reset that. We'll go through that in a minute. And actions, emergency inactive, so we're not giving it an enable signal. Again, we've got manual run because someone is running that inverter manually, and this countdown is counting down the 30 seconds, and then once the 30 seconds, like you've just previously seen, we will go into fault. We'll just wait for that to count down. So that's 18, 19, and then we'll look at the logic once we've got the fault there coming up. Okay, so we've gone into fault now, failed. That's because we haven't asked it to run, yet we've been getting a running signal. Now if we ask for this to run on the control logic, it's not going to run because we need to do a reset. So let's go emergency active, still disabled. You can see that we're in auto run, we've got the run signal from the inverter, but nothing is happening. In fact, what would happen, we wouldn't have the run signal from the inverter. So let's turn that off, and we've got the fail there. So I'm going to reset this. So reset a block. We've got healthy, we've got true, so it's counting down now. We need to get this inverter run signal or the DP or the flow switch, whatever you want to call it, we need to get that into a true state before 30 seconds is up. Now it's true, the countdown has stopped counting down, and that will carry on running with no issue whatsoever. Let's put the inverter into fault. So that's the inverter gone into fault. You can see the countdowns happening again now, and then after 30 seconds that would disable the output to that pump, and of course that would go from healthy to fail. But we're waiting for 30 seconds. Let me just put that back to normal again now. So now we're enable, we're auto run, everything is fine again. So when we go into fault, we can't restart that pump, that fan coil unit, extract fan, supply fan, whatever you want to call it, until we've reset the system. It must have a reset. So we're latching the fault, and it will not start again until the reset has been completed. Let me just take all these back to auto. So that's back to false, disabled. Let's put that to set that just to true, and we can then look at the logic. Okay, so that's all running. Let's go in and have a look at the logic now. So we've got our reset. It's a single shot timer. It once we press that, that will go true, and if that is true, the latch is off. Then we send a true signal down to this reset block here, this OR gate. So let's do that. Let's put it on for a bit longer than a few half a second. Let's put that on to 5 seconds for now so you can see it. There we go. So there's our true, our reset true into the true block there of that latch. So that's latching the signal false into there at the moment. Now the drive time fail, with the user will work in seconds, the user won't work in milliseconds, so we convert that into milliseconds by timesing it by 1000, and that goes straight into our on delay block. Now we're looking at the on delay active there. I brought the point through for on delay active, so I know when the on delay is on, and that goes to this numeric switch here. I take in the milliseconds value, and once that switch is true, I then start this timer, and this is the enable here on that switch. So on delay active is true. I then enable this ramp, and then I use a period of milliseconds, and then these are 15 seconds each. These, all I've done there is take exactly the milliseconds and divided it by 2000 instead of what, because I wanted to half that. Let's show you the ramp. We've got sawtooth mode, interval 1 second. Currently it's 00. When that is enabled, that would be 15, and that would be 15, and then the period will also be 30 seconds there when it's enabled. So let's put it into fault so you can see that. So let's we've got it enabled, so we're doing emergency inactive, so we're now starting to count up. So there's your 30 seconds, and this is divided, the 30,000 milliseconds is divided by 2000 to get those values. So 15, 15 and 30. So that is starting to count up. We're at 22 seconds now. It's 30 seconds set point. So if nothing's happened within 30 seconds, we're going to an alarm. So that output has now gone out. This is just taking it to the time delay to show it to the outside of this folder here, so you can easily see that it's counting down. And this is the fail now, because that system has failed. We've latched now the true signal there. We've latched it in the system, and basically we can't start without doing a reset. So let's put everything back to how it was. emergency auto. Again, it still won't start. We need to do a reset. Now it's started. Now that will carry on running with no issue whatsoever. Now for the drive in manual, I've used an XOR signal. So if I get a run signal and I get a false demand signal, I will put it into manual. If I get a false run signal but I get a demand signal, I put it into manual. So it's just an XOR gate that I'm using there. So looking through the logic, we've got a multiply. That's to change it from from seconds into milliseconds. We've got a mismatch alarm. So that's an XOR gate again. So if we've got an enable, yet we don't have the DP or the run on the healthy, we've got an issue there, and that's when we will actually start latching everything. So that will then go true, and if that is also, which it is also true, that will send a true out to there, and it will put a true into that in, but it will also go into this wait for the 30 seconds, and if we have 30 seconds hasn't happened, it will, this is an OR gate, so it's either one of these, that will give the true, and it will latch that clocks. So it will latch that signal, which will be true. When that goes true, that signal there, true, will go into the out, and that latches it. And the only way you can actually get rid of that is by doing a reset on the system. So if you copy this logic exactly, you have got yourself a countdown timer on your delay, and you've also, which you don't need, but it's nice to know how many seconds you've got left before it will actually latch itself, using this ramp. Now to find the ramp, it is down here, it is ramp here, utilities ramp. You bring it across, it probably won't give you sawtooth straight away. Yeah, it gives you a triangle, so you want sawtooth. And then if you wish to do it manually on 30 seconds, that would be 15, that would be 15, and that would be 30 seconds, and save that. And then you don't need to see the points, so I normally to put that to a 0, save. But I don't want this to be showing all the time, so what I do is I use this numeric switch. So when I've got my on delay active in the Boolean delay, so if you look in the Boolean delay, when I've got this on delay active, I switch the values to this output here, which then I put it into the period, i.e. 30 seconds, in this case 30,000 milliseconds, and then I also take that same value, I divided it by 200,000 to get me 15 either side, to then give me my 0 to 30 countdown. So this works if you change the, let me delete that, and I'll change this value to, I'll do it from outside the block, change this value to, I don't know, 50 seconds. Man, you have to wait quite a bit there. I'll just change it to 40 seconds. I'll fail the inverter, so it's now failed. We've got a fail time now of 40 seconds, and that will count up to 40. There's it counting there. So now, because we've got 40 seconds, we've got a 20 and a 20 either side now. And after 40 seconds, what will happen there is the delay, this out, will change from false to true, which goes into this OR. So this would be true, this would be true, and then of course it will capture that true signal there, which it has done. So nothing can happen now with that inverter without doing a reset, even if you make it healthy. So let's just make it all healthy again. So we're asking for it to run. Inverter is saying running. Inverter is healthy. We've got our fail time there, but we've still got our output there, and we've still got our fail. until we do a reset. Now the DevOps, I've written it here, what they wanted, what the client wanted. So plant start. So upon receipt of the start signal, the plant will be enabled for a period set by the delay on timer, normally 30 seconds. Plant shutdown. The system will be shut down when no enabler is present on the or the on delay timer has elapsed with no run and health DP signal. On plant shutdown, the plant will be disabled. Monitoring. The plant is monitored for their run status via the run signal and inverter healthy or DP switch. So inverter healthy, DP switch, same thing. In the event of a failure as detected by a mismatch between the BMS command and the status after a time period, i.e. 30 seconds, a critical alarm will be raised on the BMS and the plant will be commanded to off. A failed plant will not re-enter the normal automatic control sequence until the BMS operator acknowledges via a reset that the fault alarm on the plant has been cleared on the BMS. So this does exactly what it says on the tin. So if you want to use this, you're quite welcome to use it in your logic. I would normally make the block like this, and then of course I wouldn't have any of this lot here, and that's my block ready to put into logic. The enable command, the run. I think that's it. That explains it. Again, you might want to take a snapshot of this, pause the video and just rewrite this. It's not, I've left all the points so you can, I want to see where this one goes. That's just the output going to the outside to say it's running. This one is the output going to the outside to say the mode. That enabled is coming from up there on delay active. This is just the output again going to the outside of the folder for the countdown so you can easily see it. That's the same. The out enabled for the pump or the fan. That's the same. That nib there is also the output, and that nib there is the output. Let me show you what I mean. So if I go drive failed there, that's that one, and failed, I've just done that, fail countdown is that one. Sorry, I'm trying to do the drive, not that one there. Drive not fail, which is that one there. And I think you can see all the other links. If I move that across a bit more, you can see the links there. You can't see that one going there unless I lift it up a bit, lift that up a bit, try and expose these slots. That's probably better to take a snapshot of. That one is coming from there. Let's just move that further across so you can see that. That's going out, that's going out. Yeah, I think that's about it. You should be able to copy that and multiply two XORs there and there, an AND gate, a NOT gate, a Boolean delay, an OR gate there, an AND gate there, a numeric switch. Let's just rename that and put that to show time, show elapse. That's creating the view for how many delay off time is. I think that's about it. If you've got any questions, put them in the comments. But that's a nice block to have for your pump or your extract fan, just to latch it out and it can't run again until you've done a reset. Thank you for watching.